Back, and we're going to pursue structures this time with data structures. In other words, we're going to create a data structure called a list, okay, that will allow us to store data in a manner that we can retrieve based on the address where this data is. And we're going to do this within the context of structures. So we're going to build a list based on structures. So if you have a struct, basically what you have is a complex data type or a user-defined data type that has data members. So let's say we have client as a structure. Then we could have a name and a balance as elements of this client. Now, would it be nice that instead of using an array, because if we use an array, then we have a fixed size container, right? So if we used an array of clients, so let's say from clients, I created a clients array, right? What will that give us? It will give us something like this. So basically, these objects will be right next to each other, but you're going to have to set the size of this array in your code, which means if the size for this one was, like in this example, 5, then you're only allowed to have these 5s while the program is running. What if you wanted to add another object? What if you wanted to remove an object? Okay? Then things can be problematic if you're going to use arrays. So instead, we're going to use the concept of a list. So how does the concept of a list? That means we can create objects totally independent, except we're going to link them together. So I could have objects, they don't have to be right next to each other. However, inside that object, I'll have the address of the next element. Inside of this object, I'm going to have the address of the next element. And the last one, which is the tail, I'm going to ground it to null, which means it will point to nothing. So each one of these objects points to something, either null or the address of another object. Okay? So for example, this would be C1, first client, second client, third client, right? And then we need to also have another pointer here that points to the head of this list. So this is going to be important. So this will be the tail, and this will be the head. So the point, what we're going to be doing with coding is we're going to try to emulate this effect. So one of the things we're going to need is some sort of a pointer right here that can point to an element of that structure. So that pointer itself has to be of the same data type as the structure. And so is this pointer for the head. Okay? We're going to need this head pointer at all times, and the reason is we could use it when we are ready to traverse this whole list. So we could say, okay, well, let's start at the head, and as long as this pointer right here in each element is not pointing to null, keep reading the next element, right? So start at the head, move to the next element, read. Is it not null? Great, it's not. Read. Is it not null? Is it not pointing to null? Read. Is it not pointing to null? Great. And then that's assuming your list is already established. Now, what if you wanted to add a new element? Well, what's going to happen, let's say we want to add C4. So let's say we have C4 independently, and we want to add it right here, right? Or anywhere, as a matter of fact. We can insert it anywhere. But right now, we're going to insert it as if it's a stack. So the last in will be coming in. And so the way to do it is you're going to repoint this one to C3, right? Since it will have a pointer element that points to some other structure. And then you're going to take the head and repoint it here. So you can actually take this off by changing the head pointer to the address of C4. So now effectively what you have is a list of these objects. So in our next video, we're going to be watching how we're going to code this.